Hello everyone. In this lesson, we will primarily introduce the exception handling structure. Let's start with an example. The purpose of this code is to input two integers and output their quotient. When the program is run and the integers 10 and 2 are entered, the result is 5. It appears that there are no issues with this code. However, for certain special inputs, the program will encounter exceptions. The two images depict the program's execution results with different inputs. In the first image, an exception occurs due to division by 0. In the second image, an exception occurs because the divisor contains letters. Both types of inputs result in program errors and termination. The error message indicates the location of the error in the code, the type of exception, the sequence of method calls that led to the occurrence of an exception. During program execution, exceptions can occur due to various issues. To handle potential exceptions and prevent program termination, we can use the try, catch, finally exception handling structure. Here is how it is used. Place the code that may throw an exception in the try block. Use multiple catch blocks to catch and handle specific exceptions. At last, use the finally block to execute code that should be executed regardless of whether an exception occurs. We can understand the execution process of the exception handling structure through this image. First, the statements in the try block are executed. If no exceptions occur, the statements in the finally block are executed directly. However, if an exception occurs in the try block, the catch clauses are sequentially searched for a match based on the exception type. If a match is found, the corresponding catch block is executed, followed by the statements in the finally block. If there is no matching catch clause, the statements in the finally block are executed directly. After understanding the usage of the exception handling structure, we analyzed that both the input and the division of integers can potentially cause exceptions based on the exception information in the previous example. Therefore, the relevant code is placed in the try block, and two catch blocks are used to catch different types of exceptions. As a result, the code is modified as follows. In the catch block, the getMessage method, or the printStackTrace method, of the exception object E can be called to output the complete information of the exception. The finally block in the exception handling structure serves as the exit point. It is executed regardless of whether an exception occurs or not. The only exception is system exit when the system exit statement is executed in the try or catch block, which indicates the termination of the virtual machine. Usually, the finally block is used to release occupied resources, such as database connections, network connections, file streams, etc. For example, in database operations, the database connection should be closed regardless of whether an exception occurs. Therefore, the code to close the connection can be placed in the finally block to ensure that this operation is always performed. In the try catch finally exception handling structure, the try block is required, while the catch and finally blocks are optional. However, at least one of these blocks must be present. It is recommended to add a catch clause for catching exceptions of the exception type in the exception handling structure to handle potential unknown exceptions. Since the exception class is the parent class of other exception classes, it should be placed at the end of all catch clauses. Otherwise, a compilation error will occur. It is not advisable to use the exception class to catch all exceptions, as it provides no help in exception handling. Nested exception handling structures can be added within the try, catch, and even finally blocks. There is no specific limit on the depth of nested exception handling, but it is recommended not to exceed 2 levels. Multiple levels of nested exception handling can reduce program readability. The diagram describes the JVM's exception handling process. When the program reaches a certain line of code, and an exception occurs during its execution, the JVM helps determine the type of exception and automatically instantiates the corresponding exception class object for handling. If there is no exception handling method provided in the program, the JVM will use the default exception handling method, which prints the exception information and then terminates the program directly. If there is exception handling in the program, the instantiated exception class object will be called by the try block. After caching the exception in the try block, it is compared with the exception types in the corresponding catch blocks one by one. If a match is found, the catch block is used for exception handling. If there is no match, it continues to match with subsequent catch types. If no catch block matches, it means the exception cannot be handled, regardless of whether the exception is handled or not. The finally block is always executed. However, after executing the statements in the finally block, the program further checks whether the exception has been handled. If it has been handled, it continues to execute other code. If not, the JVM applies the default handling. This class mainly introduced the usage and execution process of the exception handling structure. In future code development, it is advisable to add appropriate exception handling structures to enhance the robustness of the program. This concludes the lesson. Thank you. The keyword used to throw an exception in Java is second. Regarding exceptions, which of the following statements is correct?